begin?
Started.
Good afternoon, everyone. I hope you've been enjoying the presentations this far. Right now, we'll be presenting you our project, Hydro Horizon. As our slogan says, pretty simple, we're turning tides into light. So, before we began actually brainstorming how we do this, first we needed to point out what exactly were we tackling. We decided that the three most important points were that wildlife was at risk. Our oceans in Portugal, we feel that they're undervalued. We could be using them for a lot more projects and things of the sort. So we decided that we should focus on that point as well. We'll also explain to you later on why specifically we chose water as our main energy source, aside from just caring about the ocean, because companies don't work like that. And finally, because we think that this blackout showed us that a lot of companies simply aren't prepared to deal with extended blackouts. So from these problems surged our motivations. Our motivations is to value the oceans because we are Portuguese. We were born near them. We spend most of our lives around them, so we've come to value them a lot. We'd like to promote our local economies, and probably most importantly of them, we want to make energy reliable. We want energy to be the least of your concerns while you're conducting business or whatever else you need to do.
Alright, that leads me up to try and tackle and give you guys the technical part of things. So our plan consists of 3 steps. So there's gonna be 3 phases to the plan, and this is something that's gonna be scaled and can be scaled, and we have a plan for that we'll go more into in the end. So our first step, and this is our shortest capacity, is to get refurbished EV batteries. And we use the buoys that were in the previous image. The buoys essentially harness the power from water through movement, and they convert it into electrical power. They'll be stored by the shore in facilities that may or may not already exist. That helps cutting into costs. This gives you up to 8 hours of runtime with no electricity whatsoever, just the support from the batteries. Our midterm solution is a little bit more versatile, and it lasts you for a whole day. And basically what happens in this process is, since we're already in water, this cave already exists and it's located in Castro Marim. It's abandoned, no one's using it. So we'd be using infrastructure that already exists, where we would turn water into hydrogen to produce power. All of this would be done through the alkaline electrolyzer. They essentially take the molecules of hydrogen existent in water and make it just hydrogen. And again, for our last and longest term solution, it'd be implemented in dams in Fronhas that you saw a couple of slides ago. And we would create a closed loop water pump that would create a natural battery. What this means is, if the dam is filled all the way up top, we can open the doors and it goes downstream and it generates and powers the batteries. And this solution can last you for 3 days of uptime.
So let's give you a quick example. Imagine that another blackout occurs. So we divided the priority things that we need to, give energy and supply the energy to. So the first tier is like life safety, like lightning and emergency lightning. The tier 2, it's critical, so servers and control systems, etc. And then the tier 1, the one that's not that critical, that is auxiliary services. So basically, with what Hugo said, so more or less like 3 days of energy, we could supply a company or a lot of companies, depending on the scale that we're talking about. So they don't have to, have the problem of the, blackout or the power outage in this situation.
So yeah, our marketing campaign, so you all saw our slogan at the start, and we will focus our advertising on mostly social media, LinkedIn and Facebook. And we will be attending different energy conventions and speaking at them. And word of mouth is very important too, and working with TrueNet partners. And here are our potential partners. We have Grupo Atec, which is the port, BYD, it's like EV dealerships, and GE Vernova, it's the Bujos, and the government.
Yeah, so here's the budget we have.
So here's everything we will need, and it will cost about 4,800,000 euros. And when you can sell the leftover power for a rough estimate about 32,000 euros a year, which would make you money to give in when you don't need the electricity.
So turn our tides into your power. So as we shown you in this presentation, we want to better use the oceans because we know that we have a lot of potential there and we want to value our oceans. Point two, reduce impact on wildlife. So our strategy involves reducing all the wildlife impact so they don't have that much impact. And also the CO2 emission. So we want to reduce the most of CO2 emission in order to keep a good environment. And then the last and most important one, have a backup plan for an eventual blackout. So as we've seen, the blackout caused a lot of stores to close, etc. Most companies weren't prepared, as Jose said. So we want this to be a big project, and that the companies don't have to worry about that, and that keep working for at least like 3 to 4 days, and that's basically it. This is our project. I hope that you all liked it.
Good afternoon. My name is Pedro. It is our group. We're presenting our solution, Ventolush. It's wind using wind power to power up electrical systems. It's a smart solution featuring wind energy. It includes these 3 acronyms. So basically, it's a battery energy storage system. BESS, CAES, it's compressed air energy storage, and EMS, which is energy management system. Our goals is to be blackout resilient and effective. Here is our overview of our hybrid system that will combine all those 3 acronyms. This is how our power up will be 2.5 megawatts wind turbine. It will be a 5 megawatt per hour battery energy storage system. Compressed air energy storage is for a long-term storage, while the other one is more short-term. The energy management system will serve as a control backbone, basically managing everything, making everything smooth.
Over here we have the sizing and the cost. The capacity of the batteries are usually 2 to 5 megawatts per hour. The power rating is 2.5 megawatts. The cost is usually 400 to 600 kilowatts an hour. An example here we have is 5,000 kilowatts an hour times 500 euros. That will be equal to 2.5 million. Now the system and the components and costs. We have over here all of these. We have the wind turbines, the compressed air, the batteries, and the MS. It will be a total of, on the low ball, it will be 5.1 million, and the high end will be 8.55 million.
The energy management system would be the part that Ronet will be working on, which is the management system for real-time monitoring of the electricity currents to know when the blackout or low energy occurs. In case of low winds for the wind turbines, to also kick in the backup system. The black start capability is the battery energy storage system, which is the one that kicks in the fastest, while the compressed air system needs time to ramp up until it starts working on a longer term solution. Analytics, that works. So yeah, it tracks the energy data to know when to kick in the system itself, starting with the battery, which is instant, until the compressed air storage has enough pump to keep the wind turbines working, even if there is no wind or in case of blackouts. I think this is the one, sorry. The compressed air system key features is the fact that it's good for a longer term solution in terms of keeping the wind turbines working even if there is no wind at all. It has a lower cost per kilowatt per hour. It's for more scalable, either using underground air pockets to store the compressed air, or the compressed air units themselves. While the battery system is more effective, more efficient, and has a faster response, which will be the first one to kick in, until the compressed air system can kick in and keep the system working.
So here we have the comparison. Compressed air has a longer duration, while the batteries have more efficient and responsive systems. And the maintenance costs more on the compressed air, while the cost overall is on the batteries. How these two would work together? The batteries have an instant response, that would make the time for the compressed air to start to ramp up their systems, because the compressed air has a long-term support, and they efficiate the profiting and reduce mechanical wear, and together they offer better reliability, flexibility, and efficiency.
So here we have an example of how this will work. At normal winds or high winds, it charges the battery, then it charges the compressed air, followed by, at low winds, it only charges the battery. And during extended outages, which is the important part here, the compressed air kicks in to maintain electricity for all and to help during the recovery that has the same sequence. And for developers, the key responsibilities in this case is energy management systems and SCADA, which is acronym for supervisionary control and data acquisition integration, and cybersecurity and networking, since it has computers, and design dashboard. The revenue is gonna use a service as a software as a service, maintenance and updates, plus custom integrations.
In conclusion, the EMS plus the wind plus the BESS plus the CAES is reliable and makes smart power. This is an opportunity for the EMS to enhance grid and make profit. Thank you.
Can we?
Yes.
Yes, please.
Yes, start.
Hello, everyone. My name is João.
Samuel. Gonçalo.
Casper. And Axel. And we are Polaris Link, a brand from TrueNet. We are pretty much a smart technological solution for mainly the outage, blackouts, you can go. We were gonna talk a bit about the branding before we develop more into our company.
So the branding, or the Polaris Link, is our slogan is always on course and always connected. So it refers to the northern stars that we're used to navigate and show the orientation, especially in the dark, for the northern people, and it symbolizes guidance and direction.
The problem. So pretty much we have a problem during outage, especially the most critical service that what we aim for to bring our product, especially the hospitals, a little bit of the municipalities, but especially the hospitals. During blackouts they cannot stop, especially the most critical service, like emergency room, of course a printer, that wouldn't matter, right, in the middle of a chaos. But those services, of course, they cannot stop, especially to save lives. So in terms of economic consequences, those downtime costs very much to the companies, and that's something we cannot happen, and that's what we aim to give a solution for.
Our solution is designed in a multi-layer approach in 4 key pillars. The first pillar, resilient connectivity, we implemented by creating multi paths of communication to ensure secure data transmission. We use UPS systems for reliable backup power, seamless transition in case of a blackout, for example, and for scalability depending on the client needs. The use of edge devices that offer local processing power and offline capability to minimize latency and provide essential services stay open. We manage and monitor these services using our cloud dashboard, and that also allows us to predict future issues and manage them before they happen.
Yes, so let's imagine there's a blackout. So how this system works. The first phase, it's an immediate response. It's between 0 to 5 seconds. Then the network reconfigures. And then the second phase, it's when it stabilizes. It prioritizes the computer where to put the energy. And then the third phase is like recovery phase, where it optimizes the things.
This is the roadmap to implement the project. First, we do an assessment phase to check the current system. Second, in design phase, we create a solution plan. Third, we start implementation to install hardware and software. Fourth, we do testing to find problems and fix them. Finally, we give training to the team, so they are ready to use the system.
Yes, so our pilot and go-to-market plan is to start at deploy at 3 major hospitals and show that the system actually works. We gather data and improvements, and then we also will try out at different municipalities and get this reputation, and then from there move forward and go out to bigger companies and such.
Exactly, it's pretty much what we aim for is to first show value, first show the product really works, and then we start making the profits, right?
So our partnerships, here are 4 companies that we think would suit for partnerships. So we have a partnership for hardware, partnership for connectivity, edge computing, and cloud storage. So we think these partners would be quite suitable for our idea.
Financial benefits. We aim to maximize the uptime, minimize the cost. Of course, during a blackout, what it matters is we don't stop, and of course, by companies stopping, they are losing money. That's what we aim to not let it happen. We kind of think, we consider at least that we have a fast return on investment to 7 to 14 months, so up to 2 years. Most of our companies that are using our product, even if they don't have a blackout, all the solutions, all the package, see this like a service, all the package that we are giving them, they're getting like something in return by optimizing their energy use as well and their systems. Extended backup power, 30 to 40 longer backup power than the normal generators that every hospital have pretty much. Insurance savings, and we keep the productivity high and we don't let it stop. Thank you. Oh, fuck.
Diogo, and I'm joined with Bruno, Luis, Anna, Sever, and Viola, and we are here to present Blacksite, a company for everyone.
Hello everyone and welcome. Today we would like to present you our project Blacksite. And Blacksite offers reliable and cost-efficient backup power solutions for small businesses, big businesses, and critical infrastructure. The Blacksite integrates advanced technology with some emphasis on customer support, and it's minimizing the
implementation of UPS. The 2000 volt ampere UPS can, for a small business, provide a stable backup power during a blackout. It's not permanent, it's a quick measure to prevent a blackout during some time, and costs each one of each costs 200 to 250 euros. They are a formal means to distribute power to protect equipment from surge.
we also have a solar panel solution, especially the monocrystalline solar panel that it has a long-term efficiency. We offer a kit that is easy in installation. It starts at 100 euros and provides reliable solar power and minimal maintenance.
A Zixel with satellite connection. So we provide a Zixel router. It costs between 150 to 400 euros, and it ensures uninterruptible connectivity. So basically, it's a Zixel that can be either bought, the full router, or can be done like a service. So the Zixel will be equipped with a SIM card. It will cost 50 euros per month, more or less, and it has an installation activation of 75 euros. The Zixel will have a SIM card with satellite connection from a provider that will be our partner, and what it does, it's connected cable to the WAN or LAN connection, and if it fails, the failover automatically switches it to the satellite connection to provide internet even in a blackout.
So that was like a small business solutions. We have another one for the biggest one that is like diesel generators. We have here a table with some kind of prices, and we have a real example. Imagine like Atec was not a school, but more like a company with full of computers and people working. Like if it's a blackout and we need to send everybody home, we're gonna lose so many money by hour. We expected like 200 euros per hour. So maybe if we have a generator, we can produce energy like what happened really here. So we can't lose money. We can people can work at the projects and not stop. If we 200 euros versus 12 hours of work will be this a lot of money that we're losing one day. So we have a ROI. If we don't stop and don't send everybody home to stop the projects that they were working about and the things they were doing, we have a good amount of money that we can save. This is actually our ROI between having a generator or not having anything. So we think that this can be a solution, like an easy one. Everybody can buy a generator because it only costs like 10k to 20k, so it's not like that big budget, and can be very useful in this type of situations.
And here you can now see some of our possible partnerships that we have thought about. So we have Gember and Power Products, which could provide power solutions. And we have Nosh and Zixel, which are both large and B2B telecommunication companies. And JA Solar, which is a solar power company, which would also make the idea more sustainable.
So this was basically our presentation. Of course, every equipment here is just an example, and the price is the same. It will vary between the infrastructure, if it's how big it is and how many people work on it. If you have any questions, feel free to ask.